Hello and welcome to data visualization project. This is my project which is says 20 years of crime in 2 minutes of USA. You can play this and within 2 minutes you will get to know about the crimes in USA of 20 years because we are displaying 20 years of crime. And now we will go back. How did we arrive at this? This is the global terrorism data which we have taken this as around 40 attributes, and we have only selected 5 or 7 attributes from this. And the other data set is this one from the homicide reports data set of 1980 to 2014. So our timeline will be more concentrated on this period. Finally, we have used those two and created this CSV with 10 attributes at max. How did we create the CSV? We created the CSV using the Python script and Google Refine. Python script basically what we did using Python script here was you can see that we are loading the CSV file here and mapping those into different new column names, converting the data, removing the duplicates here, and we are creating a date. We have day, month, and year, which from which we are using those data and creating a date column here, and finally writing it to a new file. And one more thing I should talk about is here we did not have longitude and latitude. We only had state. For the states I collected CSV. I downloaded a CSV from the online for which had latitude and latitude and longitude. From VLOOKUP function I had hit longitude and latitude for all the columns here in this. This won't skew the map because we are not in when we display homicide data we are not concentrating about the where it happened. It only says about the state and number of cases happened in the state, such details we are giving, so this won't really have an skewing impact on our graph. And we have done mapping of data to create a normalized structure. This is a normalized structure which we have created. So victim count of this data set goes into the fatalities, and nkill goes into the same. Even summary crime solved will go to the summary, and the summary data from the terror data will go to the summary column. Like that, each murder will be always 1 for homicide data, and terror data is always 0. This is just to differentiate between the two data sets which will be used in the future, like for visualizing the data and in the background. And you can see that there is target column which has like target from 1 txt from terror data and crime type. Even though crime type does not fit into the target, it will be we have put that into this column just for the simplicity and normalizing the table, but it will be handled through the code differentiating. And once we have done that, we arrive at this final.csv, which has longitude, latitude, and all these columns from which we are going to display the map. As you can see in this map, as like two things which says fatalities and non-fatal attacks, which will display over the timeline. The timeline is from 1980 to 2014, and you can see this graph is dynamically related to this map, this bar chart. Basically, what happens is like it says the extent of weapon use over that year in all of these attacks. So you can see fire has been involved in major of attacks. Fire in the sense like created from fire explosives and such things. As you can see in 2001, 9/11 happened, and you can see there is one column airplane which was not previously there, which basically says whatever the attack happened. And the circle diameter depends upon the number of fatalities, so it is bigger because a lot of people uh, died in this year. And the circle or colors is also one attribute which says yes or no here. And going to homicide history, you can see homicide history entirely, like it just say points, it is dynamic, and it has same effect on this graph, bar chart graph. And you can see, like if you play over the timeline, it keeps on, firearms keeps on being the bigger or the lengthier bar in the bar chart, because we could say like access to firearms is, in US access to firearms is very easy, that is causing this. At least we can conclude like restricting the access to firearms would reduce the impact of the attacks. We can draw that conclusion from this. And we can go to that graph, which is a bubble graph. Here this bubble says targeted sectors of terrorists. This is from the terror data, the sectors which has been targeted from the terrorist, business being the first, and all the circles are in ratio with each other. And one more graph here we have is victims gender from homicide data. We can see that male and female, we have like there is a huge difference. The ratio of these circles diameters can be compared because they are from the same data set, and all this cluster, whichever is in the gray color, they can be compared for the ratio. We should not compare red and gray here. How did we arrive at this data? We have a data set for that target.csv, which has two categories, one and two clusters, different clusters, and data, sum of the number of occurrences of this particular value in the data set. From this we have created this, and we can say that this is an interactive graph which is more focused about details, like as you can see, it says number of attacks and fatal attacks and non-fatal attacks in 2007, which state. You can get a lot of details from this map graph, and this graph can be used to draw conclusions, like over the years what happened and what will we conclude from it. Firearms are usage of firearms is very easy, and that is causing the impact, that has a huge impact on attacks impact. And from this is just like this can be entertaining, and this is a lot of information throwing at the user, like uh, it's it we can just understand like a lot of males are dying or being the victims of homicide attacks compared to females, and the sectors targeted from the terrorists. We can draw those conclusions from here. And this is my graph, and it is structured like this. Data goes here, and my index html and javascript is here, and target data is here. And that's it. Thank you for listening to my data story.